This is a video on naming ionic compounds. This sort of flows from the previous video on naming covalent compounds in the sense that the rules are pretty much the same. The only difference is that you're dealing with a non-metal and metal in this case. So an ionic compound, if you recall from previous videos, is a compound formed from a metal ion and a non-metal ion combined. And one of the advantages of naming ionic compounds is that you don't require any prefixes. So no need for prefixes, okay, which saves you a lot of time. But however, there is something that you do need to know other than prefixes, and that's what are known as polyatomic ions. Now for the Year 9 science course, unfortunately, you're going to have to memorize these polyatomic ions I'm going to show you very soon. But it's not a difficult concept to grasp. A polyatomic ion is basically an ion made of multiple, it's basically a compound made of two or more ions. So poly means many, it's a prefix that means many. Atomic means atom. And I'll show you the list of polyatomic ions you need to know. Okay, this is from the the Good Science textbook. So yeah, it's published by Matilda, the Good Science textbook. Okay, 9 and 10. It's on page 209. You've got a list there, a table of common polyatomic ions. I'll write them down here as well. You need to memorize these, commit them to memory. It's not that difficult if you practice. Okay, practice makes perfect. You're going to sit and stress, as a lot of my students do, in that I'm not going to be able to do this and so on and so forth. It's just going to eat away at you every single day mentally, and that's not good. Okay, that's what gives you a negative mindset and a loss of motivation. So here are the common polyatomic ions. Here's the name and here's the formula. You've got ammonium. Ammonium is NH4+. So ions are charged, if you recall. This polyatomic ion here consists of nitrogen and 4 hydrogens latched together. So it's NH4+. This whole thing is positively charged, in other words. I'll leave the brackets out. You've got carbonate, CO3, 2-. It's got a charge of -2. Carbon 8, think of carbon C. 8 usually means oxygen. It's a nice trick to use. You've got hydroxide, and that's OH-. Okay, hydro for hydrogen, H. Oxide for oxygen, O. You've got nitrate. Okay, N for nitrogen, O3-. You've got nitrite, NO2-. You've got phosphate, PO4-3-. Sulfate, SO4-2-. Hydrogen sulfate, which is the same thing, but it's got hydrogen at the front, so it's HSO4-. And you've got sulfites. That's SO3-2-. So there's 9 common polyatomic ions you need to know. As I said before, the more you work with these, the more you practice with them, the more they sort of lodge into your memory, your long-term memory. If you just sit and read over and over again, that's not going to be lodged into your long-term memory, as the research shows. So you have to really just invest yourself in this stuff, practice regularly. So let's see how this works. Let's see how we can name ionic compounds. It's actually very simple. So it's pretty much the same rules as I mentioned before with naming covalent compounds, but without the prefixes. So let's do NaCl. This is otherwise known as table salt. Step 1, write down the name of the metal element, the metal cation, I should say, first. In this case, it's Na, which is sodium. So sodium. Step 2, write down the name of the non-metal element, which is Cl, chlorine in this case. So it's sodium chlorine. There's only really 3 steps here. And step number 3, the last step, replace the chlorine with chloride. So you get sodium chloride. Okay, this is table salt. And that's it. 3 steps in naming an ionic compound. Let's do another example. This time I'll throw in a polyatomic ion. Let's do Na2SO4. Step 1, write down the name of the metal element, which is sodium. Remember, there's no prefixes here. Number 2, write down the name of this non-metal element, which in this case is SO4. So you have to recognize that SO4, this is a polyatomic ion. The S and the O4, they're basically together, okay? And that's called sulfate. That's the sulfate polyatomic ion. So this becomes sodium sulfate. With polyatomic ions, it's just 2 steps, okay? Because this is called sulfate and that's it. That's what you get. Let's do another one. Let's do KOH. All right, step 1, the metal element, that's potassium, that's K. Step 2, the O and the H, you have to recognize that as being a polyatomic ion, and that is hydroxide. Another way to think of it is that you can only have a metal and non-metal. So in this case, the K is by itself, that's the metal, and the non-metal is the OH, that's hydroxide. So you get potassium hydroxide. We'll do one more. Actually, we'll do 2 more. Let's do barium sulfur. BAS, so barium is the name of the metal, step 1. Step 2, the non-metal is sulfur, so barium sulfur. Step 3, this becomes barium sulfate. My apologies, sulfide. Okay, you have to be careful here with the names. Barium sulfide. And we'll do one more with, let's do MgOH2. Now, the first step is writing down the metal name, which is magnesium. Second step, to write down the name of in this case, the polyatomic ion. Now, the 2 here, the subscript, means that there's 2 lots of these hydroxides, right? But we're not worrying about the prefixes here, so it's just magnesium hydroxide. And that's how you name ionic compounds. You just write down the name of the metal first, followed by the non-metal second, or the polyatomic ion. And you put an "-ide" at the end if there's no polyatomic ion.